Okay, so here's part two of the video for the snake graph concept using position and velocity. And the second part is based on the fact that they're going to ask about acceleration. So find the acceleration at time t and after 4 seconds. So if we remember, velocity is the derivative of position. Well, the rate of change of velocity with respect to time is actually the acceleration. So it's essentially the second derivative of the position function, or the first derivative of the velocity function. So we already have all the information that we did in part one. We have our velocity function right here. We even simplified it. We factored it. We found all this other stuff. So to get the acceleration function, I'm actually going to just work right off of the velocity function. So this is part G probably. So G is going to be acceleration is the derivative of velocity, which is also the second derivative of position. So I'm just showing this for the sake of just being thorough, but I would just write the acceleration function a of t, and that's going to be 6t minus 12. And if they want the acceleration at 4 seconds, well, that's just going to be 24 minus 12, which is 12. Now think of the units. Velocity was meters per second. Well, this is the rate of change of meters per second. So this is actually meters per second squared. Okay, and you physics people already kind of knew that, but that's the reasoning if you think about it as slope, rate of change. If you do the slope formula on a point, or 2 points on velocity, your units are going to be divided by another factor of seconds, so meters per second squared. Okay, the next question is graph the three functions between 0 and 5. Okay, so I already actually graphed the first two. I already typed them in. So there's the position function, there's the velocity function, and the acceleration is going to be 6x minus 12. And I did 0 to 5 for 0 to 5 seconds, and there they are. Here, I'll do it so you can see all three again. And I'll change the, I'll make this one thicker. Actually, let's make this one dotted. Where is it? Dotted. I'll do this one actually thin. And thick. Okay, so we can see all three. That didn't really come out so dotted. You can almost see it. Actually, you really can't because of the glare. So here's the original, the one that goes up, down, up. The first derivative is just the parabola, and the thicker one is the acceleration. Okay, so there's the first. There's all three graphs on one in one picture. Okay, and the next question is, when is the particle speeding up and when is it slowing down? So here's a concept question. The particle speeding up doesn't mean positive velocity. That's different. That just means the particle is moving forward. The particle speeding up would mean the velocity is positive and the acceleration is positive, or the velocity is negative and the acceleration is negative. So you can kind of look at the picture. In fact, I could probably hide. We don't really need the position function for this question. So I'll just graph the two. So there's the velocity, and here's the acceleration. So the velocity is positive from here to here, negative from here to here, positive from here to here. Acceleration is negative from here to here, and then positive from here onward. So we're looking for when they have the same sign value. So like between this point and this point, both of them are below the x-axis. Between this point and beyond, both of them are above the x-axis. So we got to figure out where those points are. Well, I can do that on the graph, but actually we can do this whole question without the calculator, and we can just use the calculator to support it. Remember the number line we made for the velocity curve, or velocity function over here? That number line? So we know velocity was positive from 0 to 1 and 3 on, and we know velocity was negative from 1 to 3. Let's do another number line, but for acceleration. And what are we going to use as our special points here? Well, we need to know, sorry, I didn't realize it was cut off. We need to know, can we see it? There we go. We need to know when acceleration was 0, so we can figure out what special value we're going to use as our cutoff point. So that would be, if I factor out the 6, t minus 2, so at t equals 2, I know there's a breaking point. So between 0 and 2, like 1, this is negative. After 2, positive. In fact, you can see that on the graph. It's just we didn't know for sure what value that was. Right? Less than 2, negative acceleration. Greater than 2, positive acceleration. between 0, actually I guess we did know the values ahead of time. 0 and 1 we knew from here, positive. 1 to 3, negative. 3 beyond, positive. And now you're just looking for when are these things the same. So if let me actually just recopy the velocity one down here, right next to, so everything's lined up. 1, 3, and I went positive, negative, positive. It might be easier to see it this way. Oop, of course, assuming it doesn't get cut off on the camera. There we go. So if I just kind of like, just sort of rough sketch here, each little section. So 0 to 1 is a section, they're different. 1 to 2, they're the same. 2 to 3, they're different. 3 and beyond, they're the same. In order to answer the question of particles speeding up, I'm looking for when they're the same. So they're the same between 1 and 2. So this is part H, I guess. So between 1 and 2 and 3 and beyond. 3 and beyond, speeding up. So again, the particles speeding up when the velocity and acceleration have the same sign. So in this case, they're both negative here, and here they're both positive. Slowing down is just the opposite. Slowing down is when they're sort of acting against each other, when the acceleration is positive but velocity is negative, or when velocity is positive and acceleration is negative. So that would be basically everywhere else. So from 0 to 1, including 0, but not including 1, and what is that, between 2 and 3. And you can check that on the graph. Again, between 0 and 1 you have positive velocity but negative acceleration. Between 1 and 2 you have negative both. Between 2 and 3 you have positive acceleration but negative velocity. And then after 3 you have positive both. So you can see your answer there as well. Okay, but you should be able to, if you line up the number lines, it actually makes it pretty easy to see too. Okay, so hopefully, sorry, I got a little cut off there. Hopefully that helps you with the acceleration portion of it. And if you have any questions, of course, just feel free to ask.